Hello students, my name is Kriti Mishra and now we'll continue with our lecture on social media analytics and data analytics. Code is BCAM061 and in the last video we have studied link analysis and now we'll see the principle of link analysis. So what are link analysis? That how people are connected to each other and we will analyze those links. What are the principles of link analysis? By using link analysis, you can see your data as a network where each node is a data point and each link is a connection. Analysis can help you discover the principle that govern your data, such as how the nodes and links are distributed. How the nodes and links are distributed. Are there cluster? Are there cluster, hubs, bridges or outliers? Cluster like with some common property, if we combine the particular nodes, that will form cluster. Hubs, bridges, we have seen what are bridges. Hub when certain groups are formed, and then bridges if by removing the particular node, two different groups are formed or two different clusters are formed, that particular node act as a bridge. And next is outlier. Outlier is, for example, we'll see in the graph, okay, these are different, suppose these are different nodes. See, this cluster here, due to certain similarity or distance between each other, there is a certain minimum distance between each other, this forms a cluster. This is called a cluster, and this also form a cluster. This is a cluster. If there is a certain one node which connect these two, so this is a bridge. This is a bridge. By removing this particular node, these two clusters will disconnect to each other, and these nodes, these and these nodes are outliers. These nodes are outliers. So how are the nodes and links are distributed? So are there is any cluster, hub, bridge or outlier? Next, how are the nodes and links related? Are there similarities? As I have seen, we form cluster on the basis of certain similarities. So are there any similarity or differences, dependencies or influencer? So these are the certain key points on the basis of which we form the clusters. Similar on the basis of similarity also, on the basis of differences also, dependencies also and influences also. Next, how are the nodes and links changing over time? So how they are changing? Are there any pattern, trend, cycle or anomalies? Pattern, if something is repeating after some time. Trend, same cycle, trend cycle, that there is a particular cycle of doing something, or anomalies. So these are the different points, these are the 3 points on the basis of which we analyze the link analysis. So on the basis of the node and the link distribution, how are the nodes and links are related on the similarity, differences, dependency and influence basis, and how are the nodes and links are changing over time. Are there pattern, trend, cycle or anomalies? So these are the key concepts on the basis of, and these are the principles on the basis of which we analyze the link analysis. Next, link analysis has 3 primary purposes. So first is discover connection that match existing pattern of interest among linked entities and detect deviation from expected pattern and indicate anomalies. Next, identify new and interesting pattern that emerge from the data. For example, in social media business domains. So link analysis has 3 primary purposes. One is to discover the connection that match the existing pattern of interest among linked entities, detecting what? Deviations from the expected pattern that indicate the anomalies. Next is identifying new and interesting pattern that emerge from the data. Next, link analysis versus traditional table-based database. So what is table-based database? Table or document-based database cannot answer complex questions, especially in the presence of unknown multiple hop queries, are slow, never return result, or crash the system. Graph at a core, link analysis has many advantages. So, what is the difference between link analysis using the graph and traditional table based? So, if you have a lot of data, you have a lot of potential knowledge, but there might be hidden insights and connections that you are still missing, especially when you use table-based database. In the table-based database, if you have a lot of data, you have a lot of potential knowledge, but there might be a hidden insights and connections that you are still missing, especially when you use the table-based database. So we try to use the graphical data link analysis for extraction of insights. So multi-hop query are slow, never return result, or crash the system. Graph at core, link analysis has many advantages. Through data connection from various structured and unstructured sources, analysis lets you connect from different sources for a more complete view of information. So, what is here structured and unstructured sources? From the different social media is generally we say unstructured sources, where the data is not very much structured. We take data and then we form it in a structured for the further analysis. So generally what we get from the social media is unstructured data, and that is very large data. So structuring the data is itself a task to understand and to analyze. So graphical representation is much easier to understand the data and structure the data. Next, consistent data cleansing and entity extraction. This involves making the information consistent and unique and ensure nodes and links have the right attribute and identifiers for your analysis. Customer data model construction. This is a process of turning a conceptual model based on the information you want to find out into a logical model based on the information you have. Next is intuitive visualization and analysis. What? Intuitive visualization and analysis. This is when you view and interact with nodes and link in a link analysis chart. You can enhance your visual analysis with various techniques and algorithms such as centrality analysis, automated layout, and timeline visualization and node grouping. So these are the different concepts which we study. What are the advantages of graph, using graph at a core for link analysis? That is thorough data collection, consistent data cleansing and entity interaction, then customer data model and construction, then intuitive visualization and analysis. Next, this is a use case, that is what is link analysis in AML, that is anti-money laundering. So in AML, it is an important field in modern criminal investigation, and money laundering enables criminal to evade taxes, fund terrorism and finance other illicit activities, and this activity is a powerful tool from anti-money laundering investigation, as it can help you follow the money, identify the actor, and understand the concept of transaction. How are the nodes and link distributed? Are there clusters, hub, bridge, and outliers that indicate suspicious activities? or risk? How are the link and nodes, how the nodes and links are related? Are there similarity, differences, dependency or influence that reveals pattern or anomalies, which we have seen in the principle, that what are the principles of link analysis. Next, how are the node and link changing over time? These are the trends, cycle deviation, that insights, signals, changes in behavior or risk. So these principles also work for various anti-money laundering investigations. What are examples of link analysis use cases? So that is, one is law enforcement. So in law enforcement, link analysis can help law enforcement agency to find and monitor criminal networks such as organized crime, drug trafficking, human trafficking and terrorism. By using analysis, they can see the structure and hierarchy of criminal groups, locate the source and target of criminal act and find new clues and evidences. Next is anti-fraud. Link analysis also help to detect the fraud. Link analysis can help detect and stop various type of fraud such as insurance fraud, money laundering, and identify theft and tax evasion. By using analysis, they can identify anomalies and suspicious pattern in the data such as match, cluster and outliers. They can also check the information and sources used to fraud investigation and provide evidences and insights for prosecution and prevention. Next, security and intelligence. For security and intelligence also we use the link analysis. It helps security and intelligence agency to discover the threat and vital intelligence such as cyber attack, etc. And by using the analysis, they can study the connection and behavior of enemies from hackers to terrorism. For this, if you have seen my last video, we have studied sociogram and sociometric analysis that is also used for these to find out the behavior and the movement and the flow of information. Next is business analytics. So in business analytics also link analysis help business to obtain insights and improve their performance such as marketing, sales, customer service and innovation. By using the analysis, they can learn the preferences and behavior of the customer such as their purchase history, loyalty, satisfaction, and they can also recognize the influence and trend in the market such as their competitor pattern and opportunities. So for the business analysis also we use these link analysis principles to analyze and enhance our business, to find out our competitor, etc. So what is the difference between graph analytics and link analytics? So we have studied both graph analytics and link analysis. So now we'll study the difference between this. So graph analytics and link analysis are two related techniques that involve the virtualization of connected data. How they are not exactly the same? Graph analytics is a more general term that covers not only the virtualization but also the analysis and manipulation of the graph data such as finding shortest path, clustering and more. And in link analysis, on the other hand, is more specific and concentrates on the virtualization. It concentrates on the virtualization and interpretation of the connections and relationship within the data, such as identifying pattern, anomalies and trends. In other words, link analysis is a part of graph analytics and to both use the same graph data models. Link analysis purpose. So what is the purpose of? I think the purpose is already clear, that what is the purpose of link analysis? Link analysis serve various analytical applications that depend on understanding relationship between entities, examining connection or links within a data set, that can insights into different domains informed by attributes that characterize these links. The following are some of the uses of link analysis. What? Find matches, find anomalies, find pattern, assess influence. So finding matches, anomalies, pattern and assess influence. So these are the purpose of what? Link analysis. Next, advantages. Depending on your application, your advantages will vary. However, many professionals experience the following benefit when you use link analysis. Objective insights. So, objective insight. Link analysis can objectively capture exploratory data such as tracking where and how professionals complete tasks. Next is ease of use. Ease of use. The technique doesn't require substantial training in data collection or analysis. Then time efficiency. In rapidly identifying trends and outliers, you can apply this across many field applications. And then scalable. What do you mean by scalable? That many application of link analysis scale to fit the level of complexity you are dealing with. So these are the examples, advantages of link analysis, which is generally asked in AKTU paper. Next, what are the disadvantages? You should also know the disadvantages. The disadvantage of link analysis is limited scope in certain domains. And what are the limited scope? In some cases, link analysis cannot capture all the relevant information. For example, in work tracking, link analysis only examine the physical aspect of work, missing out on capturing the cognitive processes involved in task completion. Risk of over-interpretation. What is the risk? The risk of over-interpretation also occur in the link analysis. It could be easy to over-interpret the identification relationship, especially those with unequal distribution. You need to exercise caution to avoid make the overarching claim based on the data. Next, if for example, if the data is very much connected, if one particular node or vertex is very much connected to many of the nodes, suppose here you can see only the 3-4 node, but actually in the real life there are billions and trillions of data which are interconnected to each other. But if the data is very much overcrowded, very much linked, then it is very difficult to take a certain insight from that particular data. So there is a risk of overinterpretation also in the link analysis. So we should avoid overinterpretation also. We should pick the particular insights or connection which is relevant to our requirement. We should only pick that particular domains. Now, domain specific knowledge required. So of course, to reduce the certain risk of link analysis, you need to comprehensively understand, comprehensive understanding of the domain and the data. The same thing which I was saying, if you don't know the particular data, if you don't know what is required, if you know your requirement, you will pick only that much of data. If you don't know what is required, then it will be difficult to find out the links or particular domain which is required. In social media analytics, a connection referred to the relationship, interaction and links between user and content and platform. And these connections help analyze how the information is spread and how user engage with each other and the overall network structure. So these are the type of connections in social media analytics: user to user connection, user to content connection, content to content connection, etc., which we will study in the next video. Thank you.